So, welcome everybody. I'm a little bit late with the video this month. I've had a lot on my plate. What we're going to do today is actually a request. One of you guys asked me if there was a way to have an animation that would automatically like switch directions. And, honestly, it's not something I ever thought about, but it's a relatively simple thing to make. And it's also something that can be applied to a bunch of other things. Now, the problem is with the $time function. Your time, it starts at 1 and just starts counting upwards. So it's only going in the one direction. And the question becomes, what mechanism do you use to get it to switch in a way that you can control? And what we're going to do is we're going to use a wave, and we're going to create a very simple little switch. It's actually a super simple function that we're going to make, and we're going to use the frequency of that wave to determine how often the animation switches over. So as I bring this frequency down, it's going to keep going in this one direction for a lot longer, and then it's going to switch direction. And then if I move this up, it's going to switch much quicker. And, I haven't tested this, but I'm guessing if I bring it up to 2, it's going to go super fast. Is that the same as 1 or not? Let's see. Yeah, I think it's a little longer. Anyway, whatever. So that's the frequency, not the amplitude. So the amplitude is how tall the wave gets, and the frequency is how many times it goes through 0 to 1. So in other words, if you imagine this as the 0 line on a graph, the wave is going to go up to 1. It's going to go back through 0 down to -1 and back up again. And the frequency determines how quickly it does that. So if your frequency is shorter, it's a much steeper graph. It goes up like this, da 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 da. If it's a larger number, it's going to do it less frequently, and your graph looks more like this. So what we're going to do is we're going to take that function, because it's also using time, and you can make your own. Wave. It's a pretty easy thing to do. It's just that Substance actually has a wave function, and we don't need to reinvent the wheel for that. And what I've done is I've created this little switch, and we're going to go ahead and build it right now. I'm going to create a new substance. We're going to call this wave graph, just to make things different. And I'm going to just do a PBR. And once we've got this new package created, we can come up into the actual package, not the graph, but the package, and create a new substance function. And here we're just going to remake the wave graph that I just showed you. I'm going to go into the library, and I'm going to get this wave. And if you ever want to see how any of these are made, you can always right-click on it and open the reference. Now, because I didn't write it, it's read-only for me. But you can see this is a pretty straightforward function in and of itself. It's all working on a sine wave, which you can actually get in here somewhere. There it is. You can also get a cosine, and you can also get a tangent. And you can use any of these curves. They all do different stuff. I mean, the sine and the cosine are pretty similar, but the tangent does all kinds of loopy stuff. And you can apply the same theory that we're going to do with this little switch to other waves, and you can build your own wave system. But in the meanwhile, we're going to open this. So we've got our wave. Now, it's asking us for two things. The amplitude, like I said, it's how high it goes on either way through the 0, and the frequency. The amplitude, we're going to leave at 1. So that means that the wave is going to pass through 0 up to 1, pass back down through 0 to -1, and repeats the process. Now, how often it hits the 1 and the -1 is determined by the frequency. And for this, I want to create an input parameter. So I'm going to come back in here into my main graph. I'm going to double click on my main graph, and I'm going to create an input parameter, and I'm going to call it frequency. You can call it whatever you want, but that's what I'm going to call it. We're going to leave it as a float 1, and I'm going to leave all of this as default. So I now have this input parameter that I can put into my function. But the thing is, if we do this, that input parameter we just created doesn't appear on here. And that's because we're not really in this graph, we're in this function. So what we need to do is create an input that will allow us to take that input parameter that we just created and kind of make one of these for this untitled function that we're creating right now. And we do that exactly the same way that we do it in the main graph. I'm double clicking on the main graph of the actual function, not the wave graph. And I'm coming down here, and at the very bottom, it's got its own input parameter thingy. And this works exactly the same way. And we're going to just make a new input in the graph, and it's just going to match up with what we've made in the main graph. So now, when I get a float, my frequency appears, but it's appearing because I've created a separate input parameter within the function itself. And we're going to plug that into the frequency input on this wave function. And again, if we look at this one that actually is within Substance Designer, and it's got all the actual formulations for making this wave, if we go down to the very bottom, it's got its own input parameters here as well. And this greater than 0, by the way, just means that it's going to run, it's not going to dip into -1. So here we are. We've set up the wave the way we want it, so it's going to go through 0 between 1 and -1. And all we really want to do, I mean, you can use this methodology to do all kinds of weird and wacky stuff, and it's gotten me into the mood, in fact, to do some experimentations on these, which is kind of one of the reasons why I'm a little bit late with this video, because we're going to make a piece of water that has some waves that move in one direction or another after we've made this, just to do something useful with it. I haven't gotten the switch between one direction and another the way I like it, and I was kind of hoping to get it done for this video, but I haven't, and rather than delay the video, I just kind of wanted to show you the switch, and once I come up with the final material, we could probably do another video on it. But for the moment, let's just do this, because this can be applied to any animation, and you can do variations of this to do all kinds of custom stuff, because you're hitting these borders and you're getting it to do stuff once it hits these numbers, and it's going to oscillate back and forth, so you can just keep switching back and forth between whatever instructions you give at one end and the instructions you give at another end. After all of that talking, let's get a greater than, and I'm going to get another constant, and we're going to set up this if-else statement for ourselves. All right, so if this wave is greater than 0, then I'm going to have this be positive. If it's not, I'm going to have it be -1. And we're going to set this as our output node. So all we're really doing is taking the power of this, in this particular case, a sine wave, and we're using it to switch between one direction, +1, and another direction, -1. And now that we've got this function built, we can go ahead and apply it to any material that we make. So I've now got, oh, sorry, I gotta wait. I can't do it in here. I actually have to put it into a function. But in a minute, we're gonna make this piece of water, and we're gonna use an effects map, and we're also going to do some other stuff to it. And we can drop that function in there and just go ahead and change the direction of any animation that we do. So that's the actual viewer question that was answered. If you want to stick around and watch how I can apply this to making some waves on water, then stick around, because that's what we're going to do. Okay, So before we do anything in this effects map to actually, switch our animation around, we have to create something to animate. And I'm going to get a shape. I'm going to get this shape node here. And we are going to get the Gaussian. And this gives us a nice Gaussian spot here. But it doesn't look like much of a wave. So I'm going to get a transform 2D. And I'm going to hold down control while I do this, so it's going to move it to the middle. And I'm going to get it skinny, because what I'm looking to make right now is sort of the crest of the wave. It doesn't look much like a wave crest yet, but it's at least moving in the right direction. The problem is I only want one of these, and it's tiling it out for me. So we have to go back into the base parameters, and we have to deal with the tiling mode. And I'm going to change this to absolute, which means that it's going to be sort of separate from everything else in the graph, and it's going to go by its own rules as opposed to whatever happens in the parent. And then you'll see that all of a sudden I have access to this drop-down list, and I'm going to change it to no tiling, and that's going to make this not tile. The other thing I want to do is I'm going to bring this down a notch, and I'm going to make it one below the parent size. But what that does is it affects all the other nodes down the line that get their output size information relative to input. I'm not going to switch that here. I want to do a couple of other things to it first. This right now is very flat, and I want to put a curve on it. So I'm going to get a directional warp, and I'm going to warp it back against this Gaussian dot. That's pretty nice. You can get it whatever curve you want. But, I'm thinking, this is going to be the basic shape of the wave. So it's got much more of a wave shape now, but it's still very, very flat. And to do that, well, to deal with that, I'm going to get a Gaussian noise. And again, I'm going to bring this down to -1 off of parent size. We're going to make it smaller. We're going to get another directional warp, and we're going to use this to warp that flat line. But from here on out, I want my outputs to actually be the same as the parent size. So on this second directional warp, I'm going to come into my output size, and I'm going to change it to relative to parent. And that means that all the calculations that happen before it gets its size information from this one that's marked input. So you could have whatever you want down here. In fact, we could lower this down another notch, and it's not going to change even if I hadn't had it set to relative to parent, it wouldn't have changed this. It's getting its size information from the one that is actually marked input. But it means that we've got, in fact, let's see what happens if we bring this down one too. You see, because, yeah, this is a good example. Sometimes, if you go down too far, these numbers will start to creep back up. These are the finer points of optimization. Each one of these nodes kind of has its own sweet spot where it takes the least amount of processing power to make things go. And it's different, and it's weird, and it's a real pain in the butt to do. But I just try to use as small and as efficient a size especially if you're doing something like water, which needs to be as smooth an animation as you can possibly make it. I just try to keep all my things as lean as I can and still have them work properly. Anywho, so we've got our wave crest here. I want to see this a bit more like that, maybe even higher. Maybe that's too high. If you want, you can do whatever you want. But what we've got to keep in mind is that we're going to animate this Gaussian noise, because what we want to see happen is as this disorder changes, that's going to move. So that's kind of a cool thing, because they're going to get, each one of these, this shape is going to get its own animation in the effects map, but this secondary animation then actually keeps changing that shape as it's moving along. So that's kind of cool. For right now, I'm going to just put time on there because it's already in there. It might be a little fast for what we want, but we'll use it right now. Let's see what happens if I move this back up. Yeah, it's happier. Yeah, I mean, none of these numbers are really meaningful until we get it set into the output, so I'm not going to obsess about it too much. Okay, so we've got this wave crest, but what we don't have is kind of the back of the wave. And what we're going to do for that is, well, we're going to basically repeat the same thing, only we're going to use a directional blur off of this same original crest that we have. And let's get a couple of other nodes in here. I want to be able to lighten it up. I'm also going to I'm going to need this because we're going to need it to align it. You know, we're going to need to kind of tweak the two of them together. And we're going to need another directional warp. I'm trying to think of where the best place to, I don't think it really matters. Put it in here. Okay, let's start at the beginning of the line. Okay, I've got this thing now. A directional blur, you can change the angle of the blur. So kind of, you know, make it not quite so even. We can change the intensity of it. And then the other thing I want to do is I want to lighten it up a bit. You know what, let's hook these guys up because what's going to end up happening is this. We're going to use a lighten blend and we're going to stack them on top of each other. So now that I can see the two of them together, I'm going to come in here and I'm going to adjust my levels to where I'm happy with the way the two of these work together. If I single click on that transform 2D, I can then kind of move this around too. And finally, if we hook this back into here as well, it's going to start running on the same animation that that crest is running on. That's pretty good. And we're almost ready to plug it into the effects map because we've got our basic shape, but we're going to put this animation into the effects map where it's going to, you know, be going in this direction, then it's going to go in this direction, back and forth, but this actual shape isn't changing direction. It's just going to sit. So in other words, it'll look really weird because when the waves are moving in this direction, it looks fine. Otherwise, when it moves back, they'll look like they're moving backwards, and we need them to actually switch directions. And to do that, we're going to get a transform 2D, and we're going to go into our transform matrix. Now, right now, if we look at it now, I can change it to, I think if I do 180, it switches back and forth. But how do I actually get it to do that with numbers? And well, let's take a quick look at what, I mean, I've done this I've done this a couple of times before, but if you haven't seen those videos, let's do a quick rundown of what's going on in here. This transform matrix is in fact this. It's a float 4. It's two float 2s together. So if I have it set to its original position, it's 1, 0, and then 0, 1. If we come back in here and switch this, and come back and look at what those numbers did, it's the same configuration, only instead of 1s, it's negative 1s. Now, there are other videos where I get into more detail as to what goes on here, and I'm not going to do that right now. But what I am going to do is create a function that's just going to switch it from 1, 0, 0, 1 to negative 1, 0, 0, negative 1. And that's all we really need to have happen. And we've already got that function that gives us those very same numbers. So let's come in here, empty function. I'm going to come back into my Explorer. I'm going to come into my untitled function. Oh, by the way, once you've got it like this, even though it belongs to this graph, I could just as easily come up to the sample one I did and drag in my original. It doesn't care. It's in the library. So that's one of the other nice things is that once you've made one of these things, and that's why I give it a name like this, like wave direction switch, because it means that I can go ahead and use this in any material I make from now on. But I'm going to take our untitled function, and now I've dragged it into this transform matrix. Now it's looking for that frequency, so I have to go ahead and get that variable get float, frequency, and now it's looking at the frequency that we created in these input parameters here. And what this input is, it's looking for a float 4 output. So that's what we end up having to give it. So I'm going to get a vector float 4. I'm also going to get a vector float 2. And we want 2 of these, so I'm just duplicating that out. And so our pattern, what our result needs to be 1, 0, 0, 1 in this float 4, starting from the top, moving down to the bottom. I've got my 1s, whether it's a positive 1 or a negative 1, is going to be determined by this function. So I need this 0 to fill out the 0 spots, but otherwise, all I'm going to do is plug in the results of this function, which is either going to spit out a positive 1 or a negative 1, depending on the direction, and then this becomes my output node. Now, here's the thing. According to my notes, when I did this, I had to switch the directions, because as you're doing, as you're reusing these functions, you're using them in different spots, so sometimes your direction is literally backwards. And we may end up having to change this because things could be just different in the way that we set this one up. I'm not really paying that close attention to it. But it's no biggie, because if I want this to be backwards, in other words, if when this spits out a negative 1, I actually want a positive 1 in here, all I got to do is negate the results equally. So I just take this and I just flip it. And all this does is just makes it go backwards. So you can reuse the same function and then just change the direction this things go just by, literally negating it. So that is that. We're not going to be able to see the results of this until we actually animate it. But why don't we do that before we plug it into the effects map? Just to make, just to see what's going on. So we've got wave graph. I'm going to publish it out. We're going to come into our player. We're going to open up wave graph, and there it is. So it goes in one direction and then it flips. So it works. Cool. All right, now we're ready for the effects map. Wait a minute. I'm deciding, you know what? I'm going to get the relative to parent off of this directional warp, and I think I'm going to put it on this blend instead, because I think it's going to work a little bit better. Yeah. Okay. One more thing before we actually start doing the function in here. Right now, we have this one shape. Now, mind you, the shape is changing constantly, which is cool, but if we start having a whole bunch of them iterate in here, it's going to start looking pretty suspicious, because they're all going to be doing exactly the same thing at exactly the same time. And, we could go ahead and remake this, however many times, but again, that's going to be a little difficult computationally. I'm going to duplicate this guy out, and I'm going to change its random seed. And then I'm going to get another directional warp, and I'm going to take the results of this and do something else to it. So we now have 2. Let's see how different they look. Another thing we can do is change the size of these, which will probably be better, because if we change the size, make this bigger and then make this stronger, it'll actually change the shape of the wave in a more profound way. Because I'm not really worried about these edges so much as I'm worried about the shape of the wave. So now we have 2 very different looking waves. And they're going to be moving in 2 different ways, because what we've done, we've changed the size. In fact, we can make this more efficient by making it a little bit bigger. I don't think it really affects this all that much. We can take that up a bit, kind of compensate a little bit for it. Yeah. Yeah, it's just making, I think, for a more efficient material. Yeah, because the tighter you get these, the more processing it takes. So we have this one, and we have this one. So that's 2 very different looking waves. And we're going to plug the first one in, and then we're going to plug the second one in. And they don't go into the background, they go into the input image. And then to get to the effects map, we're going to right click on the effects map, edit effects map, and it brings us in here. I'm going to get an iterate node, and this is going to determine how many iterations of the wave we have. I'm going to set it as my root. This first node should always be set as your root. And let's get another quadrant in here. I'm trying to remember how many I had on my original. I think I had everything on the third quadrant. So we're going to have two different images, so we're going to need two on this third level. I'm not going to highlight this. I can press space, and if I don't have it highlighted, it's not going to automatically draw the noodles. I'm going to hook up a couple of these, and let's get one of the images in here. So we'll start with the first one. Okay, and that's kind of small. In the I think in my when I was experimenting with this, I did. I think I took care of the size. I think I did have 3, but I took care of the size in the random. I think I'm just going to go ahead and do this though, because I think that's really the size, you know, the basic size that I want it at. So we'll call this 1 if it goes, you know, some can go a little bigger, some can go a little smaller. But I think this is a good basic size, and this way we don't have to make up for it in like weirdnesses in our function. Because I ended up having a random number between 0 and 2. Doesn't matter, there's more than one way to skin a cat. Okay, so we have our shape in here, and now we need to start doing things to it. In order to keep things simple, we're going to put everything on this first color luminosity channel. So we're going to come in here, I'm going to do empty function, I'm going to click on it, and that's going to bring us into the luminosity channel itself. First thing I'm going to do, because it's a good habit to get into, is set up the last bit of my sequence. And since I do want this image to be not see-through, I'm going to set that final thing to 1, because that's what the actual luminosity channel wants. Now we need to start moving these things around. Okay, so the first thing we're going to do is our offset, which is an XY value. It's a float 2. So we know we're going to need to vector a float 2. But here's the thing, it's actually going to be split up between two kind of functions. One of them is going to be the animation over time, so that's going to be moving on the X back and forth. But the other thing we need to do with our offset is randomize the placement of the actual images. And it's easier to think of it as two different steps. So let's start with one step, and then we'll do the second step, and then we'll just kind of join the two together. I'm going to get my time, and I'm going to get an operator, multiplication, and I'm going to get a constant. And the plan that I have for this material is, you know, once we get these waves finished, there's going to be kind of an underlying sort of water undulation going on as well. And I want to be able to sync the two of them together, because they don't seem to run on the same, anyway, they don't seem to run on the same time. I don't care, because all I need to do is fool around with this constant, which I have set in here as 0.5. And that's just going to adjust the speed at which both of those move. So that's what that's for. The next thing we need to do is determine the direction in which this animation is going to go. So we want to go back into here and get our little wave switch. And we're going to get our frequency, because it's not going to work without it. And so we've got that hooked up. And what we're going to do is we're going to take the result of whatever this time number is, and we're going to multiply it by either the +1 or -1 that's getting spit out of that function. And we've gone over this before, and I'm just going to do it now because I don't feel like explaining it again. I'm going to get an operator add, and I'm going to get another constant, and I'm just going to put the number 10 in here. It doesn't really matter what number you put in here. And I'm going to add it to the result of this. And the reason I'm going to do it is I want this to start off randomized as far as the placement goes. And we haven't actually done the placement yet. This is just the time end of it. But the timer starts at 0. And it doesn't matter to anything that we're doing here if the timer starts at 10. But we need to have a number other than 0 for the randomization to work, because the randomization is actually a number between 0 and 1. And if that number is, if we're dealing with zeros, everything's lined up. So I don't want things to start lined up, which is why I'm putting this in here. I'm going to get another constant. I'm going to set this to 1. And we're going to get a couple of random nodes. And this is going to take care of the actual starting position and the randomization of where these things get spit out. And that is plugged into our x and y values. And since we want them to be randomized on both the x and the y, they each get their own random number. Now we got to hook the two of these up together. Let's get another one of these. Oops, don't know. I only needed the vector flow 2. This movement I only want happening on the y. I mean on the x. I don't want it to move on the y at all, because we're only talking about whether it's going this way or that way. So I'm going to do that. So we now have our position and our time, our animation. And I'm going to get another multiplication. And because these are now both float 2s, we can just multiply the two of them together, and it'll take care of what needs to get taken care of as far as what gets multiplied with what. And this is our offset. So I'm going to set a new variable, and I'm going to call it, I'm going to copy that, and then I'm going to come back out into my effects map. I'm going to go into my offset, and because it's not on that drop-down list, I have to actually create an empty function, add node variable get float 2, and since it's not there, we're going to have to paste it in, and then set this as my output node. And if we plug it in here and set this as the output, then it's doing the offset for us. So yeah, I mean, like if we went and did this, it's lining up like that, and I don't want it to do that. That's why I did that. Okay, so that's the offset done, but they're all still the same size. And that's what we're going to deal with next. Actually, we can use this same number 1 here. Okay, so we want our sizes to also be random. I'm going to do a couple of those because I do want them to randomize on the x, not nearly so much as on the y, but I think that would be, I think it'll just add to the variety of the waves. So we're going to have 2 different numbers here. But I'm thinking, I think I do want them to go bigger than this. So I'm going to get the number 2, and I'm going to use that as the base for my randomizations on the size. And you know what? I want to be able to see what I'm doing. I'm going to go ahead and hook this up before we go any further. So I'm going to get another sequence node. I'm going to get a vector float 2. We're going to hook up these results. Oh, blind. That's my sequencer. We're going to put this in here. We're going to get a set variable, and we're going to call this wave size. I'm going to copy it, go into my effects map. I'm going to come into my pattern size, create an empty function, get my float 2, paste in my wave size, set it as my output. Then I'm going to come back into my color luminosity. We're going to plug this in here, and we are going to, what am I doing? Plug this in here, and now we see what we have to deal with. And this is why we want to handle the numbers differently. So first thing, I really don't want the y value to be less than 1. So let's take care of that first. So I'm going to get a comparison, and we're going to get an addition node. So, oh, we also need a if else. Okay. So if the results of this is less than 1, let's have it be 1. Otherwise, we'll have it be the result of this. And that is going to be our y value. You know what? I just realized I put this plus sign out here because I actually wanted to do something else with it. Let's have it instead of it being 1, let's have it this number plus 1 because it'll give us more variety. Okay, so we got rid of the squishy ones. I just want to fool around with this number just a little bit to see whether, I want to see how far out I'm happy with it going on the X. Let's make it 2.5 because I don't mind them being stretched out like this. In fact, I think it's good to have more variety. And let's do the same thing. I don't want them to get super skinny either. I'm going to duplicate this. This is all very confusing. I'm just going to get rid of this. Okay. So if the results of this number between 0 and 2.5 is less than 1, then I'm just going to have it be 1, I think. I'm not going to get more complicated with it. Well, it depends. It really depends on how much variety I want. I mean, how in the aggregate, how many of them I want smeared out. And do I want some of them relatively skinnier and some of them more smeared out? Let's try it like that first. And we can always put that addition in later. So I'm going to do 1 in here. Otherwise, we're going to use the results of this random. And then we're going to replace that way. So that looks pretty good. Let's take a look. Yeah, I'm pretty good with that. I mean, the only thing that I'm not happy with in this material, and that's including the, like the final version of this, is that switch, when they switch from one direction to another. And it was giving me a hard time, and it's still giving me a hard time, and I'm still working on doing a better version of it. But I decided not to hold back on this, because once we're done with this, without that switch, it actually makes a pretty decent wavy material. It's just that changeover that I'm not happy with, and it's just a function that needs more work. But so far, so good. I'm pretty happy with the waves that are happening here. We got them going at different speeds, and it's randomizing nicely. Okay, let's move forward on this. So we've got the basic wave thing going on. What we're going to start doing now is building a super basic material off of it. We're not going to get fancy. I mean, this is, it's more about the, how you get all this stuff to work than worrying about the colors that we're going to use. So feel free to expand on this at home. What I am going to get is a gradient node, and let's assign some colors to our waves. I like that, and we can use this for our color. My 3D. Oh, I need to set up my height. All right, so right now all we have is the color. And I'm not gonna fool around with the opacity. Again, you can do that at home. You can add an extra output for opacity. I'm gonna switch these guys around because I like it this way. And I'm then gonna go to the library and get a height to normal. And let's take the results of this and put it in here. Now, this was one of the other things that was hanging me up, and I still haven't figured out the answer to it. See this artifacting? I don't get nearly so much of it out of here, and I've been doing some. It's to do with I think it's the way it handles bitmaps, but it's this one. Yeah, it's something to do with the effects map, because when you plug in the thing that is getting plugged into the effects map, I'm not getting that. Don't know why. I'm working on figuring it out, but I do have a bit of a workaround. Curvature smoothness is gonna deal with that to a certain extent. It wants a grayscale. I mean, it wants a gradient backwards day. And if I plug it in here, it evens. It doesn't get rid of all of it, but it gets rid of a bunch of it. I'm going to hit D to dock that. I think I'm going to come into my effects map, and I'm going to move the global opacity up a little bit. Oh, I meant to single click that. And I still have a, because this is supposed to be smooth water, so this kind of ruins the effect. The other thing that we can do to make it a little bit better is to up the surface size a bit and then have the sampling go to Sobel. In fact, let's try to bring this down as far as we can because it starts to sample just around the edges. So that's a big improvement over what it was before. And we can plug that into the normal. So those are the waves on a purely glassy surface. And that's, not really very realistic. So what I'm going to do is, I don't know if we might not need this. I'm going to duplicate this. And I'm going to duplicate this. We've got these pretty small, and I want the reason I'm not using the same one over and over again is I want them on different timings. So I'm going to change that random seed again, and then whether or not we change the sizes, we'll figure out in a minute. And I'm going to get a blend node, and we'll use an overlay blend. And let's see what that looks like. It's a bit overwhelming, I think. Let's get a levels node in here. Somehow this ended up, my 3D view ended up in here. Yeah, that's irritating. I just keep grabbing them out and putting them in the wrong spots. And if you have the 2D and 3D view on top of each other, it defaults, it's irritating. It just keeps switching to the view I don't want. Yeah, that's overwhelming. So we need to bring this down and flatten it out. That's probably good. So let's take a look at and see how it looks right now before we do anything else. Okay, so far so good. I think I'm liking the size and movement of the underlying water, so I think for the moment anyway, we'll leave that alone. What it's not doing is changing direction along with the waves. So we have to get it to do that. But as far as the sort of the micro, the secondary animation on it, I think it's okay. It's starting to look pretty good, actually. So we need to apply to, well, this. Let's put a transform in here. We need to apply a direction that corresponds to what's going on in this effects map. So we actually have that open up here. We want it to work exactly like this. So I'm going to copy that. I'm going to come into my transform 2D. I'm going to go into the offset, make an empty function, click on it, and then paste in that snippet that I took from the other node. This number may change, but this is pretty much it. Only problem is it's expecting a float 2, and it won't let me set it as an output node. So we need to get a vector float 2, and we're only having it work along, we only wanted to actually animate along the x-axis. So I'm going to put this result on the x. We're going to put the number 1 in here. I'm going to set that as the output node, and we should be good to go. So let's take a look and see what happens when we publish that out. Yeah, okay. So it's changing direction. But I think it's moving about twice the speed of the waves. It's easier to see actually if we bring the frequency all the way down. I'm watching the ripples, and the ripples are actually moving a lot faster than those waves are. When I was doing my experiments, this number ended up being 2.5. So let's see how that works. Yeah, I think that's a bit better. I mean, you can tweak the numbers how you want. I'm going to leave it like that. We're almost there. We're going to get our height done next. I don't know. I haven't decided. Do we want to put? Okay, the question I'm asking myself right now is: we have an opportunity to make a height map directly off of this normal, or to do it off of this. In which case, the small waves are only going to be handled by normals. Let's try it this way first. It's not giving me that. Well, it's giving me that crest. And let's see what happens if we get a normal to height. I'm going to get the HQ version. Okay, I'm going to split the difference. I like this. Let's see what happens if we... okay, how about instead of lightening this up, we'll darken it up. What I'm trying to do is get the ripple heights not to have so much white in them. Yeah, but that flattens out the normals too. I do like that. Okay, so we'll leave that for the normals. We're going to get a second levels node. We are going to probably not do it this way. Let's try something different. I'm going to use a lighten blend here. What I'm trying to do is get the entire wave higher than the ripples. So it'll still have some height stuff happening, but none of it is happening as high as the waves. Okay, let's take that for a test drive, see what happens. But we need to set it up in here too. I'm going to stop this for a second. The height sets up in here exactly like you set it up in Substance Designer. I think that water is also wiggling too fast. And that is to do with this. So we're going to come in here. Right now, all we have on the disorder is just time. So we can go in here and actually just edit it. And we can multiply it by a number. I will try 0.25. I have no idea what a good number is, but it should be somewhere around there, or maybe 0.5. And let's export it out. That it's still moving way too fast, I think. Let's come back. Now I think the back and forth action needs to get sped up a little bit. Yeah, I think that's a little better. Is it moving in the right direction? Oh, you know what it's doing? I think it's moving in the opposite direction from the waves, which is a distinct possibility. In which case, all we need to do, yeah, I am in the right, I just want to make sure I'm negating the right thing. All we need to do is to get a negation and just invert whatever's coming out of here. Let's try that. There's something weird about it. It's throwing itself at me. Yeah, I think that was it. Right. So, and you can play with that at home. There's one more thing I want to take care of before we finish this up, and that is to give it, well, a couple things. I'd like to be able to speed up and slow down my animation. And I'd like to be able to get, to have control over how many waves I iterate. So we're going to make a couple of new input parameters. We can have animation speed. I don't know, we can make this a number between, you can do whatever you want. It's just a number. But this will give a slider that'll affect whatever timings we have. And then we also need wave iterations. And this is going to be an integer. And we do want a minimum iterations because we don't want 0. And we can have, let's set the default at 3, and we can have the maximum at 10. I'm going to clamp it because I don't want anybody to do 0. So now let's come back in here and add in our animation speed. I'm going to put it immediately next to time because I want, I don't want to do it after this step down because it's a whole number. So, it's time multiplied by whatever. I'm going to get my variable. And that should work. Well, actually, I'm just going to do that. I'm going to copy that. And our other animation is here. Oh, I did that. Okay. I thought I was here. Okay, so we're going to put it in here as well. And, well, it works. I just don't know if I like the number setup as far as the defaults go. Because if we look at it, honestly, we really don't, I don't think we really want it above 3. And I don't want all this slider up here, so I'm going to change the default to 3. But other than that, it seems to be working fine as far as, speeding things up and slowing them down. And finally, we are going to come in here into our iterations. And all we need to do is just add that function in there because that's just going to be a direct one-on-one thing. It doesn't need anything extra. Oh, you know what we didn't do? We've got our actual effects map. We only have the one wave type. We never copied this out. So I'm going to duplicate this out. So I want 1 and 4 on this one. Because this is going to give us 2 wave types. So I'm going to the second one. The only thing I need to change now is the input image index. And I'm going to change that to the second image we've got in there. And if you want to do more, you can. I mean, you're welcome to put, more of these guys in here. But remember, every time you do it, it's costing you. So let's take a quick look at that. Oh yeah, baby. That's nice. I'm liking that. We need to make that slower again. I forgot to do that. So I'm going to double click on my main graph, animation speed. We will bring this to 3. And we'll make the default, I don't know, 0.5. Yeah, okay, cool. This actually came out better than the experiment that I had done earlier. I'm still not happy with the switchover, but as far as the wave's concerned, these have potential. I mean, obviously they could be made to look a lot cooler, but the bare bones of what needs to happen is here, and it's working pretty efficiently. So I'm going to call that done, and you can take this and run with it. I'm going to get rid of metallic. This is black. If you leave it blank, it's black. If you want, you can put a color in there. But it's done. So cool. I'm pretty happy with this. Yeah. So that's Constantine's question answered and a piece of water with waves done. And, I right now, I don't like the switch. So if I was going to use this, I would just do it unidirectional until I could figure out, because I don't like how it's like a hard switch. I want to figure out a way of softening it a bit. But that's what experimentation is for. So I'll see you guys in the next video.